In this video, we are going to look at the second part of Mathematics Paper 1 internal for the year 2017. Now, this part will consist of questions beginning from question 14 up to question 23. So let's look at the first question. Two boats X and Y leave spot P at the same time. X travels on a bearing of 159 degrees and Y travels on a bearing of 215 degrees as shown in the diagram below. After some times, X and Y are at point such that angle PYX is equal to 41 degrees. So the first step that we are going to do is we need to draw vertical lines at each edge. So begin from here. So this line, then we indicate our north. We also draw another one here. We put our north. Then for this one, we are just going to extend. So that is our first step that we need to do. Then also you need to commit to memory that each line that we have drawn, they are parallel to each other. So the first question here is find the question A, bearing of X from Y. So we need to identify which line represents the X and which one represents the Y. So the line where the bearing is coming from should always be a vertical. So since the first one is coming from the Y, so this one, this vertical line, this is our Y. So this one, the one that is slanting, where Y and X, the one connecting Y and X becomes the line of X. So we are going to move from this Y in a clockwise direction until we touch this line of X. So this is the angle that we are looking for. Now from this angle you can see that we have the angle 41 degrees. So we need to find the angle, the other angle. Then if we add, we are able to find the actual angle. Now, so what we are going to do is we are going to find this angle here. So that is what we are going to do as our first step. Now for us to find this angle, we are going to look at it. We have this angle of 215. So this 215, we will subtract it. We are going to subtract 180 from 215. So let's write our 215. Then we subtract our 180. So 5 minus 0 is 5. 1 minus 8, that's impossible, so we take 1 from 2, becomes 11 minus 8, we have our 35. So that is our angle here. So here we have 35, also here we have 35. Since these are alternate angles, they are equal to each other. So now for us to find this angle of the bearing of X from Y, we are going to add 35 plus 41. So 35 degrees plus 41 degrees. So here 5 plus 1 is 6. 4 plus 3, that is 7. So our angle is 76 degrees, but an angle in terms of bearing should be given in a 3 digits format. So we add a 0 at the beginning. So this becomes 0.76 degrees. So that's our angle as our first answer. Then for question B, the bearing of P from X. So let's go the bearing of P from X. So this bearing is coming from X. So this line here becomes our X. So we are going to move from this X in a clockwise direction until we touch this one. So this is the angle that we are looking for. Now, so here we are going to look to first find the angle here. So since we have this 159, we can subtract 159 from the straight line, which is 180. So let's say 180 minus 1 minus 159. So this should be minus. So 0 minus 9, that's impossible, so we get 1 from 8. 10 minus 9 is 1. Here we have 7. 7 minus 5, that is 2. So we can see that we have an angle of 21 degrees. So if the angle here is 21, also this angle is also 21. So we can see that if we complete this one, will give us a circle. So a circle adds up to 360. So 360 minus 21, then we have this bearing. So if we get 1 from there, we have 10 minus 1 is 9. Here we have a 5. 5 minus 2 is 3. Then so the bearing of P from X is 339 degrees. So that is our answer for part B. Now let's move on to question 15. Misozi and Filamba estimated the length of a line to be 9 centimeters and 10 centimeters respectively. If the true length of the line was 9.6 centimeters, find the first one. Misozi is absolute error. So let's begin by writing the formula for the absolute error. So is equal to recorded value minus true value. Okay, so now let's look at the recorded value. So we can see that according to the arrangement of these two individuals, the first one is Misozi. So Misozi corresponds to the first number, which is 9, and Filamba corresponds to the second number, which is 10. So the estimated value for Misozi is 9. So here we are going to put our 9 centimeters minus the true value is given 9.6 centimeters. So if we do math, we are going to get negative 0.6 centimeters. Now the final answer should always be a positive. So after removing these absolute symbols, our final answer is 0.6 centimeters. Now, for maybe if you have issues on how to subtract numbers like this, so we are subtracting 9 from 9.6. So we have 9.6, then minus 9, which is 9.0. So 6 minus 0, that is 6. 9 minus 9, that is 0. So that is where we are getting our 0.6. Now the reason why our 0.6 is negative, because of the bigger number, which is 9.6. Now from there, let's look at Filamba's percentage error. So percentage error is equal to absolute error divided by true value times 100%. Okay, so let's now also find the absolute error for Filamba. So this will be absolute error is equal to recorded value for Filamba is 10 centimeters minus the true value is 9.6. So if we subtract 10 minus 9.6, we are going to get 0.4 centimeters. So this is our absolute error for Filamba. So the reason why we are using for Filamba, because it is the percentage error for Filamba, the one that we are looking for. So we can now proceed 0.4 centimeters divided by our true value 9.6 centimeters. So this is a ratio. The centimeters will cancel, giving us 0 0.4 times 9.6 times 100. So we can so first we are going to get rid of the decimal. We multiply the numerator by 10, so 0.4 times 10, even the denominator by 10. So the reason why I'm multiplying by 10, because we only have one decimal place. So here we have 4 over 96 times 100. So we can reduce 4 into 4 is 1 over 4 into 9, that is 2, remainder 1. 4 into 16, that is 4 times 100. So if we simplify it, we are going to have 100% times 1, that's 100, divided by 24. So if we reduce let's reduce 4 into 100 is 25. 4 into 24 is 6. 6 into 25, that is 4.2%. So this is our final answer. So that is how we can find the percentage error. Now let's move on to question 16. Now question 16 reads, it is given that t is equal to k times v squared, where k is the constant of variation. So using the information given in the table to find the first one, a, the value of k. So here we are looking at variation, and we are lucky that this time the equation has been given. So let's look at the equation. Is t is equal to k times v squared. So we are going to find the value of k. So let's look at, we are going to look at the first column. So the first column, our v is equal to 1, our t is equal to 4. So where there is t, we substitute with 4. K is what we are solving, 1, that is 1 squared. So if we proceed, 1 times 1 is 1 times k. So k is equal to 4. Now for part B, value of a. So we write the formula, t is equal to k v squared. So we are solving for a. So a is in the row where there is t. So where there is t, we substitute with a. So a is equal to k, we have it is 4, multiplied by our v. Our v is 5 squared. So a is equal to 4 times 5 squared is 5 times 5, which is 25. Then if we multiply 5 times 4 is 100. So this is the value of a. Now the question C, we are solving for the value of b. So the formula is t is equal to k v squared. So let's look at b. So b is in the row where there is v. So where there is v is where we are going to substitute our b. So t, let's look at t. T is 36. Our k, this is 4 times v squared. So 4 times v squared is 4v squared, divided by 4, also by 4. So v squared is equal to, so 4 into 36 is 9. So we are solving for v, which is same as the b. So we introduce the square root, also here the square root. So if we cancel, v is equal to positive or minus 3. So therefore our b is equal to plus or minus 3. So that's our answer. Okay, now we can move on to question 17. Question 17. In the diagram, A, B, C, D, E, and F are points on the circumference of a circle. FBD is equal to 70 and AEF is equal to 20. So the first question, explain why AD is a diameter. So why AD is a diameter. So for AD to qualify to be a diameter, it has to cut the circle into two halves. Okay, so now let's see how we can qualify these. So from the point, we can see that here we have 70. Even here we are going to get 70. So this is these two segments chords are originating on the same point. So if we have 70 here, even here is 70. So same applies. We can see if here we have 20, also here we are going to get a 20. So if we add 20 plus 70, this angle is equal to 90. So angle ACD, so angle ACD is equal to 90. Since this angle is equal to 90, therefore this ACD is a semicircle and AD qualifies to be a diameter. So that's the reasoning behind. So we can say because AD cuts the circle into two semicircles, giving us an angle of ACD equal to 90 degrees. So that's the reason why AD qualifies to be a diameter. Now let's move on to question ACF. So ACF. So AC, we can see that we've even answered this one. This is equal to 20 degrees. And the property behind this 20 degrees, we say that angles in a same segment are equal. Since angle AEF is equal to 20, angle ACF will also be 20. Now let's go to angle DEF. So DEF, this angle here. So we can see that if we are to find angle AED, this angle is equal to 90. So for us to find DEF, we are going to add 90 plus 20. So let's say DEF is equal to 90 plus 20. This is giving us 110 degrees. Now the advice that I can give to you, my viewers, under this topic, if you want this topic to make sense, please make sure you understand the all properties that are given on this circle theorem. Otherwise, it won't make sense. Now let's move on to question 18. So question 18 reads, question 18a, it is given that PQR below is right angled at R, QR is equal to 4 centimeters, and tan QPR is equal to 4/3. Find sin PQR. So from the trig ratios of SOHCAHTOA, for us to find sin is found by sin theta is equal to opposite over hypotenuse. So let's look at the angle in consideration. So we can see sin. So the angle in consideration is Q. The angle in consideration is Q. So if this is our angle of consideration, this is our opposite adjacent, then hypotenuse. Now from there we can see that for us to proceed, in order to find the sine PQR or sine Q, we need to have the opposite and the hypotenuse. So for us to find these two distances, we are going to look at the given tan. So the given tan, so tan is equal to theta is equal to opposite over hypotenuse. So from there we can see that this number here, our 4, is opposite, then our 3 is adjacent. Now under tan, the angle under consideration is angle P, so this angle. So if we consider our tan, our 4 is our opposite, then here this is where our 3 is, so we have 3 centimeters. So this tan is helping us to give us this distance of 3 centimeters, and since we have a distance of 3 centimeters and another distance of 4 centimeters and a right angled triangle, we can use Pythagoras theorem to find the value of hypotenuse. So let's find this distance. So this distance, let's just consider this one as PQ. So we'll say PQ squared is equal to QR squared plus RP squared. So PQ, we'll just say H hypotenuse squared, then QR 4 centimeters squared plus 3 centimeters squared. So if we square this, 4 centimeters squared giving us 16 plus 9. So H squared is equal to 16 plus 9 is 25. Then here we can find a square root, also we can find a square root. So our H is equal to 5 centimeters, since the square root of 25 is 5. So this is the distance that is here. So after we have all 3 distances, we can now proceed to find sine. So sine, we said, if we look at sine, this is our opposite, then hypotenuse and adjacent. So opposite is 3 centimeters, hypotenuse is 5 centimeters. So if we cancel this, our final answer is sine Q, or we can say sine PQR. So let's just use PQR is equal to 3 over 5. So we'll just leave it as a fraction, since they also gave us tan Q as a fraction. Now let's proceed to question B. The ratio of the surface areas of 2 cubes is 16 to 25. What is the volume of the smaller cube if the volume of the bigger cube is 500 cubic centimeters? So we begin. We have 2 cubes. We have a smaller and the larger. So the smaller has 16, then to 25. So whenever you are given surface areas, the first step that you are going to do is we need to find the square root for each ratio. So let's find the square root of 16, also the square root of 25. So square root of 16 is 4, then square root of 25 is 5. So these are known as the scale factor. The scale factor as the numbers that we are going to use now for us to find the final answer. So after finding the scale factor, let's go back to the question. The question is find the volume of the smaller cube if the volume of the bigger cube is 500. So this 500 will be written here. So our 500 cubic centimeters here. Then here we are going to put x, since we are solving for the volume of the smaller cube. Then we can cross multiply. So 5 times x is 5x. Then for 4 times 500, I'll just leave it like this. Then divided by 5 also divided by 5. So you can see the reason why I left it just like that. So I know that 5 here is 1. 5 into 500 is 100. So 100 times 4, we get 400 cubic centimeter as our volume of the smaller cube. And it's making sense 400 is less than a 500. Now from there, let's look at the question 19a. A businessman bought 300 company shares at 60 kwacha. The nominal price was 30 kwacha. How much does he pay for the shares? So a businessman bought 300 companies shares at 60. Now this 60, we don't know if this 60 is for each share or maybe for the all shares. So this question is incomplete. It's not that making sense, because this step, we don't know if it was for the all 300 shares or maybe it was for each share. Okay, so this one is not making sense. Let's move on to question B. The equation of a straight line L is given by, so we have an equation 2y is equal to 4x minus 5. Now find the equation of the line passing through that and is perpendicular to line L. So we can see that we have negative 2, 3. So we have x1 and y1. Then the formula is y minus y1 is equal to mx minus x1. So y1 and x1 points are given. Our work is we need to find the gradient of this line. So for us to find the gradient of this line, first let's find the gradient of line L. So first we need to make y the subject of the formula. So we are going to divide by 2, here by 2, also here by 2. So if we cancel, we have our y is equal to 2 into 4x is 2x minus 5 over 2. Now after we are done making y the subject of formula, so we need to substitute y with letter m. Then the coefficient of the x is the gradient of that equation. So the coefficient of x, we can see, is positive 2. So this is now the gradient of line L. Now we are looking for the gradient of this equation which is perpendicular to L. So let's find now gradient 2. So since we have been given the condition of the perpendicular, if one gradient is a whole number, then the gradient of a line that is perpendicular should be a fraction. Then also the sign changes. So since we have a 2, this one becomes a fraction, which is 1 over 2. Then the sign changes from positive to negative. If it was a fraction, you just need to flip the fraction where the denominator comes a numerator. So this is the gradient that we are looking for. So now let's proceed. So y minus y1 is 3. The gradient is negative 1 over 2. Then x minus x1 is negative 2. So let's now simplify. So here we can see negative times negative 2 is positive 2. So y minus 3 is equal to negative half times x is negative half x. Then negative half times 2 is negative 1. Then we can collect the like term. So this negative 3 will move to the other side, giving us y is equal to negative half x minus 1 plus 3. So the sign changes. Then our final answer is y is equal to negative half x plus 2. So this is how we can find this equation which is perpendicular to line L. Now let's move on to question 20. Now question 20. The diagram below shows a cone with apex V and radius R. How many planes of symmetry has the cone? So the cone, the base of the cone is a circle, and the circle has infinite number of planes of symmetry. So the answer for the first party, we can say it has an infinite planes of symmetry. You can't count them. Or what you can just do is you can always commit to memory. A cone with a circle as a base has an infinite or a countless number of planes of symmetry. Now let's move on to question B. The diagram below is an incomplete program flowchart to calculate the curved surface area S of a cone with base, radius, and slant height L. Complete the flowchart by writing the appropriate statements in the blank symbols. So let's first begin by finding the curved surface area. So curved surface area, the formula is pi r. So pi r L. So this is our curved surface area for a cone. Now from there we know that a pi is constant, and since it is constant, we don't consider this one as our input. So from there we are going to look at this polygon here. This is what we call a parallelogram, and this one is used to show the output and the input. So the input is radius, and height. Then we have the rectangle. Rectangle is used to show the process. So the process is curved surface area is equal to pi times radius times L. Then we are done. We have completed this flowchart. Now let's move on to question 21. So the question reads, write down the four inequalities that define the unshaded region R on the diagram below. So let's number this. So let's consider this one. 1, 2, 3, then 4. So let's begin with the 1. So number 1, the first inequality, we can see that this line is cutting the x-axis between -2 and 0. So we can say x -1. Now let's look at so this area is less, then this one is greater. So from this line 1, we can see that the shaded is less, the unshaded is greater. So we are looking for the greater one. So we use greater than or equal to. Now number 2. Number 2 also is cutting the x-axis at +4. So this one is x4. Then this line is, area is greater, this one is less. So from there we can see that the unshaded is on the less part, so we use less than or equal to. Let's look at Roman number 3. For inequality number 3, this one is cutting the y-axis at 6. So it is cutting the y-axis at 6. Then this area is greater, then the lower is less. So the unshaded is on the less party, so we use less than or equal to. So for the inequalities where each party is cutting one of the two axes, it is just simple. You just look at the axis that line is cutting, then and the number. Then from there you consider the line that is under consideration. Now from there, let's look at our equation number 4. Now this one is touching two axes. So the first one, this point here, it's 0, it's 0 comma negative 2. So in the y axis, the x is 0 comma that particular number, then x is 2 comma 0. So we have 0 comma negative 2 x1 y1, 2 comma 0 x2 y1. So let's find the slope. So slope is equal to y2 minus y1 over x2 minus x1. So y2 is 0 minus y1 is negative 2 over x2 is 2 minus x1 is 0. So 0 negative times negative, we have positive 2 over 2 minus 0 is 2. 0 plus 2 is 2 over 2. Our gradient is equal to 1. So for a line that slants like this, gradient is always positive. Then for a line that is slanting, this one, the gradient is negative. So we have a positive one, so we are okay. Now let's proceed by finding the equation of this particular line. So y minus y1 is equal to slope times x minus x1 in brackets. So y1 is negative 2. Our slope is 1. x1 here 0. So negative times negative is positive 2. What is x is x. 1 times negative 0, that's negative 0. Then we are going to move our positive 2 to the right side. Y is equal to x minus 0 minus 2, which is minus 2. Then our final answer, let's go back here, is less. Then this region is greater. So we can see that the area that we are interested in is the greater one. Now we have a dotted line, so we're just going to use it greater than x minus 2. So this is our fourth inequality. Now let's move on to question 22. So question 22, if y is equal to that, find the value of x for which y is equal to negative 2. So we have been given this equation. So the equation is y is equal to 1 minus negative 2, 1 plus x minus 2. So instead of, if we expand this algebraically, we are going to form a quadratic. Then after forming the quadratic, we are going to use maybe formula or factorization, regardless of the formula that you're comfortable with. So the best way is we are going to substitute here with the given value. So the given value for y is negative 2. So negative 2 is equal to negative 1 comma 2x. So we have been given a factorized question already. Then upon reaching this one, we are going to move our negative 2 to this side, giving us negative 2. Then the sign will change to positive 2 is equal to 1 minus 2x, then 1 plus x. From there, we can see that negative 2 minus negative 2 plus 2 is 0, is equal to 1 minus 2x, then 1 plus x. Now, since we have here 0, we are going to equate each bracket to 0. So 1 minus 2x is equal to 0, or 1 plus x is equal to 0. So now let's solve for x in each equation. So 1 will shift to the other side, giving us negative 2x is equal to 0 minus 1. Negative 2x is equal to negative 1. you divide by -2, also by -2. So the first value of x is half positive, half, since the two negatives will cancel. Then the other value, we can have x is equal to, if this one shifts to this side, we are going to get -1. So these are the two solutions for the first part. Now let's look at the question B. The sketch shown below represents a section of the curve y is equal to x open bracket x minus 2. Then find the coordinates of the points where the curve cuts the x-axis. So let's look at it. Our equation is y is equal to x, then x minus 2. So we can see that we have been given an equation that has been factorized for us. So whenever you have a situation like this, please do not expand. So the first step that we are going to do is we need to find the value of y. Now the value of y on the x-axis is always 0. So where there is y, we put 0. 0 is equal to x, then x minus 2. So from there, we are going to equate the first value, this x is equal to 0. Then the second value is x minus 2 is equal to 0, which is x is equal to, if this -2 shifts to the other side, we get +2. So the first coordinate, we can see that 0, 0. Then the other coordinate is 2, 0. And it's making sense. We can see that this point here is 0, 0, since its origin. Then here it's 2, 0. So these are the coordinates of the point where the curve cuts the x-axis. So we are looking at the curve is meeting the x-axis. So where the point where the curve meets the x-axis, the y coordinate or coordinates is always equal to 0. Then Roman number 2, what is the minimum value of the function? So for us to find the minimum value, let's expand. So we will have y is equal to x minus 2. So we are going to expand this, then the second one, this. So y is equal to x times x squared minus x times -2, that is -2x. So we have formed a quadratic equation where we have our a, our b. So for us to find the minimum value, we can use the formula of b squared minus 4s. Now since a, we don't have the c value, the constant, let's find the value of the x coordinate for the turning point. So x coordinate is equal to -b over 2a. X is equal to negative, what's our b? The b is -2 over 2a. Our a, the number in front of x squared, the coefficient of x squared is 1, which is negative times negative is 2 over 2 times 1 is 2. So the x value, the x coordinate for the turning point is 1. Now after we have found the x coordinate for the turning point, we can find now the y. So let's look at the y. So x is 1 minus 2, then 1 minus 2 in brackets, so again to get -1, then y 1 times -1 is -1. So this is our minimum value. So the y coordinate of the turning point denotes the minimum value of that particular function. Now let's move on to the last part. So question 23, the diagram below shows the speed time graph of a car journey. Find the acceleration during the first second. So this point is our initial, then here our final. So we can now find the acceleration. So we know that acceleration is equal to final minus initial over t. Our final velocity here 30. Then our initial is 0 since the line is originating from the origin. Then our time, we are told in the first 5 seconds, so divided by 5. 30 minus 0 is 30 over 5. 5 into 30 is 6 meters per second squared. So that is our answer. Then question B, if the total distance traveled was 825 meters, find the value of t. So this value of t is what we are solving for. Okay, so now let's look at the shape that we have. This shape, if we are to, so this is a trapezium. So trapezium, distance for trapezium, distance is equal to half a plus b times the height. Now the total distance is given 825 is equal to half. Now the a, this distance here on top, this is our a. So our a is from 5 to 15, so that is 10, plus our b is from here up to t. This is our b, so we can just put t since we don't have the value of b. Then our height from this point up to this point, which is 30. So 825 is equal to, we can reduce 2 here is 1, 2 here is 15. Okay, so we have is equal to 10 plus t is equal to 15. Okay, so instead of expanding, let's just go direct. We divide by 15 here and also 15. So if we cancel, let's see, 10 plus t. Now let's see, divide 15 into 825. First, let's reduce. So 5 into 8, let's use here. Okay, so 25 over 15. So 5 into 8 is 1, remainder 3. 5 into 32 is 6, remainder 2. 5 into 25 is 5. 5 into 15 is 3. Again, let's reduce. 3 into 16 is 5, remainder 1. 3 into again 15 is 5, so 15 into 825 is 55. So we have 55 here. So we are going to collect the like term. This will move to this side, giving us t is equal to 55. When 10 shifts to the other side, it becomes negative 10. Then our t is equal to 55 minus 10 is 45. So this is our value of t, 45. Okay, so now let's move on to the last part. Find the average speed for the whole journey. So average speed is equal to total distance divided by total time taken. So the total distance is 825. We have been given over total time taken over 45. Okay, so let's reduce. Let's reduce 5 into, we once did this part. 5 into 825 is 165 over 5 into 45 is 9. Let's see, we can still reduce. 3 is common. 3 into 16 is 5. So into 165 is 5 over 3 into 9 is 3. So our final answer can be written as 55 over 3, or 3 into 5 is 3 into 5 is 1, remainder 2. So 3 into 25 is 8, remainder 1 over 3 meters per second. So this is our average for this question. So that's it for this video. For those that have not yet subscribed, please do so. Subscribe, hit the notification bell so that you are notified. Then leave your comments in the comment section below so that I know where I can make the videos. So thanks for watching.